Okay, hi everyone. Just giving everyone a minute to join us. But I do want to take the time to welcome you. My name is Raven, and I am an enrollment specialist at the Data Incubator. We are a fellowship, scholarship, and placement company. We have promised you all an excellent info session. So we're going to go ahead and get started. All right, so like I said, we've promised you an excellent info session that will be led by one of our instructors, Robert. Robert will be reviewing how to explore SQL with Datasette. To start things off, I would like to give you a quick overview of our programs and everything that we will offer. Then I'll hand it off to Robert, who will lead us through our admissions discussion, and we will leave some time for questions at the end. Today's session is scheduled to last 1 hour, including our Q&A. All participants are muted to enable speakers to answer as many questions as possible. All questions should be submitted in the Q&A box. The chat box will be used for general announcements and resources. Please avoid using the chat box to ask questions for the panelists. If you have questions, please email admissions at the Data Incubator, and we'll get right back to you as soon as possible. We will be recording this session, and we'll send it out to all registered attendees approximately 72 business hours after we conclude the session. So next, I'm going to pass it off to Robert so that he can introduce himself to you all.
Thanks, Raven. My name is Robert Schroll. I'm one of the instructors here at the Data Incubator. I have a background in physics. I was studying physics all over the place, actually. Before I finally admitted myself, I wasn't really having fun doing that. What I was enjoying, though, is playing with computers and doing data analysis. So I switched over to data science, and I've been here at the Data Incubator for the past 7 years. It's a little bit scary to think about, mainly because the time has gone so quickly. I have a lot of fun talking about computers, talking about how we can process data with computers, and teaching people how to do all of that stuff themselves. And yeah, I look young in that picture. Back to you, Raven.
Rob. All right, so the Data Incubator focuses on training people to become data scientists and data engineers. Why is that important? It is really because data professionals have the ability to work with the latest tools on unstructured and structured data to drive business value. This is a big need in the world right now. We work with companies in a variety of industries, ranging from tech to finance to retail to healthcare and many more. Every company has data and wants to use that data to drive value for them. So what makes the Data Incubator different? So there are a lot of other data-focused programs out there. So I'm sure you're wondering what we do at the Data Incubator that's a bit different. What we found is that you'll look at 2 different types of training. So the first would be fast-paced and efficient, and then the other would be slower and focuses on understanding and completion rates. University is one example where you'll receive a more detailed understanding, but with a lot more time invested. On the job training is usually very quick and efficient, but maybe you're not understanding what you're doing. We've taken all of these aspects and combined them together to find a great middle ground for training. Our program is fast-paced, so you walk out of the program knowing a lot about data science and data engineering. Most importantly, the program focuses on the real-world business applications of what you're learning. All of our instructors are PhD and master's holders, and many of them have completed this program themselves, so they know how to provide that in-depth training that you're looking for. So just our program offerings for a summer of 2023, we'll be offering 3 data-focused programs. So we're offering our successful full-time data science fellowship program and a more flexible version of that, our part-time data science fellowship program. We are also offering our new full-time data engineering program. I want to take some time to review the similarities and offerings for all 3 of our programs. So I want to begin by saying all of our programs are intense. They are built around hands-on data-focused curriculums. We offer both full-time and part-time programs, and both are packed with a lot of information and tools. They're thorough. Each week focuses on a different data tool or approach. In addition to our lectures, we have our students participate in hands-on practice. We really believe in fostering an interactive learning environment. And so in each program, students will work on many projects that focuses on the data tools you are studying. Additionally, our programs are very collaborative. We want students not only to work with their colleagues and instructors, but to also have the opportunity to network and connect with our hiring partners. All of our programs are career focused. We have career coaches that help you succeed in your data-focused careers. You will not only learn how to present your best self by attending our career search workshops, but you will also have the opportunity to work with the #1 resume writing company to get you a polished resume and cover letter. Lastly, all of our programs are interactive. Every student in all of our programs are provided a Jupyter server for the duration of the course, so students can follow along in lecture and see and edit raw code that's being run. Students will receive immediate feedback via our interactive grader. For our full-time data science program, it's going to last for 8 weeks with classes held daily. So you can expect to dedicate about 40 hours per week in class, working on assignments. Here is just an overview of our full-time curriculum broken down by week. But if you would like a more detailed curriculum, of course, you can email us and we'll send that to you. And followed by that is our part-time program, which is going to last for 20 weeks. Classes are held on Tuesdays and Thursdays from 7 p.m. Eastern Time to 9:30 p.m. Eastern Time. And you can expect to spend 10 hours per week working outside of the class. Office hours are available each week as well. You will receive the same excellent curriculum and training as our full-time program, but at a slower pace. The sessions are live and instructor-led, so you are still able to interact with your instructor and ask questions. Full-time data engineering program. So this is also like our full-time program because it's going to last for 8 weeks with classes held daily. So of course you can expect to dedicate about 40 hours per week in class and working on assignments. And here is just an overview of that full-time program. But like I said before, if you would like a more detailed curriculum, then you can email us at admissions@the-data-incubator and we'll get that right out to you. So that is just a little bit about TDI and our programs. I'll now pass it off to Robert to lead you through our presentation, and I will come back on the end to help answer any questions.
Thank you, Raven. And I think it looks like I am sharing my screen correctly.
Yep.
Make wild gesticulations if I'm not, please. Yeah, so today I want to talk a little bit about actually 2 pieces of technology. The first is SQL. SQL, a language for querying databases, and then a specific tool where we can use SQL called Datasette, a relatively recent entry that I think is pretty cool and I wanted to share with all of you. And I know in the past we've had a number of all of you being interested in learning a little bit of SQL, which is absolutely great. But for those of you who don't know about SQL, let's just start with a very, very quick background. What is this SQL thing? Why should you care? And SQL is a way to talk to databases. What is a database? A database is just a server that is storing tabular data. Tabular data, those are tables. Think of these like spreadsheets. In fact, spreadsheets in some ways often end up acting like databases. So each sheet you have in a spreadsheet, that could be a table, and then you have different connections between those different sheets. Together, they form a whole database of these tables. Tables are just a series of rows. Each row has a value in each of the columns that it's supposed to have. And then SQL just becomes a language that lets us ask questions of databases. We have a bunch of information in there. SQL lets us go and pull that information out. We describe the information that we want, and behind the scenes, a SQL engine turns that into some code that will actually go through, parse all the data that's stored on disk, and return you the answers. And SQL is a very old, well-established language. The very first versions of SQL were developed in the early 1970s. So 50 years old or thereabouts right now. But it's not a dead language. It's not something that people are using just out of inertia. In fact, a new version of language was just submitted for approval this month. So it is a continually growing, expanding language with a lot of users out there. And it's good not just for databases, not just for these big tabular databases, but a lot of different data storage services or systems offer a SQL interface to them. So things like Spark or BigQuery or these big distributed data storage systems offer SQL interfaces, offer you the ability to write SQL on them, even though they are not sort of the traditional database form. And because of this, I think I can say fairly confidently that SQL is the most demanded language for data professionals. Data scientists, data engineers, data analysts, all of them are better if they speak SQL, because so many of the tools out there, databases and otherwise, so many of the tools out there all communicate via SQL. However, as you're trying to learn SQL, you might run into a little bit of a problem, namely that these traditional databases aren't the easiest things to set up. And the reason for this is back in the 1970s, when these things were started, computers were very expensive and slow. And a database is a relatively demanding program. It needs to parse a lot of data very quickly. So the solution was to buy one big, expensive, reasonably fast machine, host your database on that, and then all the people who needed to talk to the database would have a lightweight client running on a cheaper, less expensive machine. And they'd send their queries into that main server, and the main server would run the queries and send the answers back to all of those lightweight clients. And this is how most of the standard SQL databases today work. Things like Postgres, MySQL, MariaDB, Oracle's database server, Microsoft SQL Server, all based on this idea that there's a central database machine that should be guarded and maintained very carefully, and then everyone can go talk to this. And this is not a bad way to do things. These databases often contain very important data for the company. Having a central place for that data that everyone can talk to and communicate through, that is powerful to handle all the needs of the organization, is a very good idea. But it does mean that the installation and configuration of these systems can be a bit complex, and perhaps not so nice and easy for that new user to come and explore. Fortunately for us, there is another project out there called SQLite. SQLite is a database engine that runs on your own machine. Database is simply a single file you have on disk, and it runs directly in whatever process that's trying to access it. So none of this large configuration, nothing where you have to worry about user permissions or identities, or any of this. Just one file that you can access on your own machine. And this is great when you're building any sort of application that needs a database with only a single client. And that probably describes you as you're trying to learn SQL and you're trying to explore a little bit about the data that you happen to have. Arguably, SQLite is the most deployed bit of software in the universe because all sorts of programs use SQLite to store data internally. I wager on your cell phone, you probably have a very large number of SQLite databases at this moment. Your web browser is using it to store your browsing history and your bookmarks, for example. So it's a wonderful, powerful piece of software. I think some people see the name and they are a little bit turned off because it looks like maybe it's a toy, it's light, but no, it is a full-fledged SQL engine, but one that operates on a very different style. And in fact, one that's very good for us as people learning a little bit about data science to be able to play with a quick SQL engine. Highly recommend it. That said, there is a downside. And the downside is, while you can interface with SQLite from the command line or from a number of other tools or from a number of programming languages, these interfaces are generally designed for experts. It's very good at that. But if you just try to use the default interface on the command line, the SQLite 3 command, well, there you go. What am I supposed to do? We could ask for help. not exactly the most user-friendly interface here. It's certainly powerful. You can write all sorts of queries here, but it's really designed for someone that already understands what's going on. This, of course, is a problem with a lot of software. It's all very good once you already know what's going on, but until you get to that point, it can be a bit difficult to use. And that's why I want to introduce the last component of the things we'll be talking about today, this project called Datasette. So Datasette is an open source project built by this fellow Simon Williamson. Sorry, I just bungled his name there. That's designed to be a tool for exploring and also even sharing data. And it's built on top of SQLite. So it's a wonderful little tool available completely for free. And as I said, it has this very cool feature that it lets you then publish your data where everyone else can explore. We won't be looking into that today, although if this is a topic people are interested in, do let us know, and maybe that can be a future webinar where we show that off. Instead, today, we're going to focus on the fact that it runs on top of SQLite and provides a nice interface that lets you write some SQL code on whatever data you have and start seeing the result. So if you're learning to, or if you want to start learning a little bit about SQL, yes, there are services out there that give you an interface to some prepared database, but I think it's a lot more fun to have your own data, something that you're curious about. Datasette is a great way to get yourself set up very quickly to explore your own data with SQL. Now, Datasette is relatively easy to set up and use, but it still takes a little bit of fiddliness. So what we've done is we've provided here a Git repository, and the link to this should be sent out in the chat. Yep, thank you very much there, where you can all just play around with this yourselves. You're welcome to clone this repository to your own Git repo if you like, but you don't even need to do that to use it. Instead, all you need to do is hit this Open in GitHub Codespaces button, which, after I say, yes, it's okay, is going to create something called a GitHub Codespace. Basically, what's happening is GitHub is starting a little server for me living out there in the cloud. And it's going to install a bit of software on there, including the Visual Studio Code interface that gives us an IDE to interact with this computer running out in the cloud. Every user on GitHub gets a certain amount of free usage. It is, let me check my notes here on the number. Sorry, the notes are not showing up. 120 core hours per month. That said, when you start it up, usually you need at least 2 cores. So you're looking at, say, there's 60 hours a month of usage just for free from GitHub. So we've hit that button there. It started up a server, and we've added a little bit of configuration to this repository so that it went ahead and installed Datasette and a couple of other useful packages. And then it even went ahead and started up, or is starting up right now, our Datasette server. This can take a minute or two to get going, so you do have to wait a little bit. But I think it is up and running now. And I think, in fact, I was a little bit slow and missed the button that lets me go ahead and open it in the browser, but that's down the notifications button there. So if I click this open in browser, it's going to go redirect me to the Datasette application that is running here on GitHub Codespaces. So it really is that easy to get going. We just have to click the button. It's not running on my own machine. It's now running out here on GitHub's service for us. Oops, and I already have the data loaded in. I thought I did not have the data loaded in, but we'll go ahead and load it in anyway, again for you. So I want to take a look at some data that we found here on Kaggle. This is a database of astronauts that someone has put together. And especially with SpaceX's super heavy launch recently, I've been sort of curious about all these people that have been flying into space. So if you click the download button here, it'll let you download a CSV file. CSV is just a common tabular data type. And then let me go ahead and just remove the existing data. No. Oh, astronaut's there. Sorry, I thought this was going to be gone when I started it up, but it remembered it from the last time. Let me just delete that, and then we can load it in again. So what you will see when you start here is something like this. And then over here on the right-hand side, we can click this menu and upload CSVs. So I've already gone ahead and downloaded the CSV from Kaggle. So I'm just going to go drag and drop it in here to upload it. It's going to ask me the table name create, but astronaut seems good. I can, come on, you can work. Hit the upload file button there. It's going to take a little while to load that in, process all of the data. And now that CSV file has been loaded up for us to interface with here. So we can see there's a bunch of astronauts. It's limiting us to just, I think, 100 rows here at the beginning. But there's many more of those in the data set. And for each astronaut, actually, we have a row for each of their flights that they've taken. So in addition to the number of which of them reaching space, we have their name in their original language, although these Cyrillic characters, I think, are being misinterpreted here. Sorry about that. Some information on their details, where they came from, when they were selected to be an astronaut, how many flights they went on, and then information about the flight in question. So quite a lot of information here, but there's actually a couple of problems with the data as it got loaded in. One, for some reason, we ended up with a duplicate ID column. So SQLite will automatically make this row ID column for us, but I guess the CSV file also had an ID column in, and they seem to be exactly the same. Also, there is this field 21 column. This is actually a problem in the original data set. There's a field, the 21st one, presumably, that they didn't tell us what it meant. So I'm just going to get rid of those. So I can do that up here, clicking this gear button here to edit the table schema. And we'll go down and find these two columns that we don't want. The ID column, we already have the row ID, the field 21. I don't know what that is. Just click delete on both, apply changes. And then if we go back to our astronauts table here, those columns are gone. And I could use that interface to fix any issues that I notice in the data. If that's the wrong data type, or if I want to fix any of the column names, I can do that through the edit table schema button just fine. So there's a lot of information, but arguably a little bit too much information here. Let's reduce the number of things we're looking at just so we get a better understanding. So while these numbers are useful or interesting, perhaps, I don't really care about them right now. So I can click on the column and say, I just want to hide that column. And you might notice that the page refreshes. So every time we make a change, we actually get a new URL of the dataset application that describes exactly the data we're supposed to see. So if you like a particular view of it, you can just bookmark that page and always come back to it. So let me get rid of a couple of these other columns here. Don't care about that. The original name, there's something wrong with the display of that, so let's just hide that as well. And maybe I don't care about when they were selected either, so I can hide that column. And I could go hide some of the additional columns there as well. But wait a second, our goal here was not just to play with Datasette, it was to learn a little bit about how SQL works. So behind the scenes, there is a SQL database here. And in fact, all these operations that I'm applying here just by clicking things are just running queries on the SQL database. And we can see exactly what they are with this little link here, this view and edit SQL link. That's going to open up another interface here that displays the SQL query that was run, as well as the result that comes back. But moreover, now we get to edit that. Now we get to see what happens as we start changing those queries. Now, the SQL language is relatively flexible in its syntax, that it doesn't care about white space or new lines or any of these things. So the default query it gives us is all smushed onto one line. That's hard to read. But I can just click this format SQL and it's going to rearrange it to a different order. And now we get an idea of all the things that are in here a bit better. And we'll notice that those columns that are listed here in this select clause are exactly the columns that are showing up in this table, which suggests how we can start organizing the things that we want to see and the things that we don't want to see. So if I want to say get rid of the mission number and the total number of missions, I can just delete those from this query string here, click the Run SQL button, and now I have another table that has omitted those things. Again, we get a specific URL for this that I could bookmark if I want to take a look at this in the future. And you might also think here, well, probably the order of these things. Does that matter? They seem to be showing up in the same order down here. Well, let's try it out. Let's say we want to compare when they were born, when they were selected to be an astronaut, and when they were actually flew their mission. Well, we have all three columns now. We just move them next to each other. Click the Run SQL button. And yeah, it turns out that order of the column names determines how they show up here. Now we can see all together what these three columns are. By the way, I should point out here that I love getting questions when I'm talking. So if you have questions about anything I'm showing you, please don't hesitate to drop them into that Q&A box. I will do my best to keep an eye on that. And if I see anything that's relevant for what I'm talking about, I will get to them. Or more general questions, of course, we'll get to them at the end. Now, there's a slight annoyance here that once I write my own query, you've noticed that all these things I could click on go away at this point. So that is a sort of limitation here. The reason is every time I'm clicking on something, I'm building a new query. And Datasette doesn't want to sort of erase the work I've done here when it builds that new query. So let's just go back to that table again. I can click the data here, the astronauts table, and see what are some of the other things we can investigate. Well, for example, there's this year of birth. So I might say, when was the earliest, or not when was the earliest astronaut born? When was the astronaut that was born earliest born? Well, if we click on this, we can see sort ascending. So we click that, and now we can see that John Glenn apparently was the oldest or earliest born astronaut in 1921, although maybe he has a tie here with Georgi Berigovi. Or what if we want to go the other way? But if we click on this again, now they are sorted the other way around there. Now we get the people born earlier or latest. 1983, that's actually older than I might have expected. Part of this may be how far does this data go? And if we looked over here, right, we'll see that there is a year of selection, but I was going to go over to year of mission. What's the latest mission year we have here? This will give an idea of the latest flights they have. Well, again, we can just do that sorting thing. So we'll sort descending here. and scroll for a little bit to see these things. Maybe I should hide some of these columns, but apparently 2019. So Datasette is probably about 4 years out of date now, and maybe that's why so we don't have a few younger astronauts in there. But again, we can ask, how did all this work? How did were we able to figure out which of these were, look at the wrong notes, that's why I'm confused. How are we able to figure out which of these are should appear at the beginning or the end of this? And to do that, once again, we can view the SQL and start understanding how it made that expression. So again, formatting it will help us read it. That beginning is that select with all that information there. There we go. There's an order by clause, and we tried to order by the year of the mission. So that's why it did it that way. Now you see this DESC keyword there. That is telling us how the ordering should be done, namely a descending order. So we start with the highest and go down to the lowest. So let me clean this up a little bit here. Subtract some of these things that we don't care about from this. Again, using the knowledge from before, and get all those years together for us. Year of mission and year of selection. Why not? We'll pull these three things to the same place. Run again. And now we get the query and we see, yes, the data here is 2019. If I want it in the other way, what if we remove that keyword? Now, if I scroll down, yes, we're sorted from the earliest mission going forward. We can also consider other things that the dataset interface doesn't necessarily expose. So let's see, each year, maybe we want to order the flights in that year by the age of the astronauts flying them. So what if we add 2 columns here? Year of mission and year of birth. Run that SQL. And now you can see in each year, for example, here at 1962, we get the John Glenn first, and then Walter Schroll, and so on, increasing by age. And yes, you can learn about all these sorts of commands in any SQL tutorial, but here's a place where you can just start exploring them, trying them out, see how these different things interact on your own data set. I'm going to get rid of a lot of these columns right now, I think, just to help us do the next step that I want to investigate. So the thing I'm curious about at this point is, how old are people when they launched on these missions? That's not a column we have in our database, but we do know when they were born and when the mission is. So what if we do a bit of math on that? What if we take the year of the mission and subtract the year of the birth? We'll see if we'll be able to understand this. And yes, it does. It tells us how old, more or less, right? We don't know the date of either the birthday or the mission, but more or less how old all these people are when they're flying. Now, you wouldn't be able to guess this, I'll admit, but it turns out in SQL, we can rename columns with the as operation. So if I want to just change this to age, or age at mission, let's say, I can use this as keyword there. And now this column has a new title for us. So who was the youngest astronaut to fly? Well, instead of ordering by the year of the mission or the year of the birth, just order by that new column we've created. There we go. 26. Flew as an astronaut at 26. These two here. And if that doesn't make you feel like you've accomplished nothing in your life, I'm not sure what will. I guess some of you may be under 26 and you still have that chance to fly in space. What about the oldest ones? Well, we saw if we put the DESC, descending keyword in there, it'll go the other way. So oldest to flight was John Glenn, and some of you may remember that as a senator, he flew on the space shuttle, evidently back in 1998, to become the oldest person to fly to space. A little bit of exploration here. Let's go back to the data and try some other things. So again, into the astronauts table just to get started. I'm going to hide a couple of these columns to make it slightly easier to read. That should get us the main things we care about up here. And I might be curious how many different flights these people have been on. It turns out there's this total number of missions column that tells us for each person how many missions they flew on. And this database is a little bit, or this CSV file is a little bit perhaps confusing in that each row corresponds to a single mission. So for example, with John Glenn here, we have 2 missions for him in both of the 2 columns associated with him. So if we want to examine one, we can use this facet option of Datasette. So if we facet on total number of missions, for example, now we can select that number that we care about. And it's telling us here how many rows we have associated with each of those numbers. And if I want to see only those that have flown, for example, on 7 missions, which is pretty impressive, you click that button. And now we get just those rows. So if I scroll down here, instead of seeing a bunch, I just see those 14 rows. In this case, it's 14 rows for just for 2 people, each of who flew 7 times and therefore has 7 rows in this table. Jerry Ross and Franklin Chang Diaz. I found it somewhat interesting that both of them were selected as astronauts in 1980, which I guess makes sense. That's right when the space shuttle was getting started. So lots of missions there to fly. Seems to be sensible. So they did suggest a number of things to facet on, but let me turn off the faceting that we've done here. See the full data set again. Turn it off. I did it twice, I guess. Which is, we can also facet on other values, even the ones that aren't suggested there. So for example, nationality. What are the different nationalities of people who have flown? So I can select that column, facet by that. We get a bunch of different options here. And one that I happen to know is somewhat interesting. If I can find it in the list down here. Oops, may have to expand the list there to see all of them. There is one person who has flown from the Republic of South Africa. This was Mark Shuttleworth, who, among other things, helped found Canonical, the company behind the Ubuntu Linux distribution that I use. Again, we can ask how this was managed, and you can do that with the View and Edit SQL button. Again, format the SQL to help us see it. And we see there's a new clause that has been added, this nationality clause. And it's going to say, or this where clause there, where it's checking where the nationality equals some particular value. In this case, there's a parameter that's being put in there that I'm allowed to adjust. So if I adjust that, that's going to be fed in at this point. So if I wanted to change that to US, for example, now we get all the people from the US there. So we've learned a new clause here by poking around with Datasette. I want to go back to this one here, our example with Mark Shuttleworth. And if we take a look at his occupation, it is, let me hide some of these other ones here so we can see it a little more easily. We see that it is other brackets space tourist. What other occupations have flown into space? So this is not something I can necessarily facet on because there might be a bunch of different others in there. However, what we can see up here is that there's a little interface where I can start putting different filters on it. So right now we have a filter that the nationality should equal Republic of South Africa. So I can also go over here and say occupation. Now I don't want it to be equal. I want it to contain something. So let's see all of the things that contain the string other. So if we apply that, well, we actually just get the one here because we're also filtering on Republic of South Africa as nationality. So I want to get rid of that. Click the X there. Apply this again. And now we get all of the people that are listed as others. Most of them being space tourists, but apparently one journalist here flew in a Soyuz flight. And once again, we can dive a little bit into that SQL to see how it's happening. So click View and Edit the SQL there. Again, format it so we can read it a little more easily. So now it's using this like clause, this like expression. So this is how SQL compares different strings. It checks whether these two strings are like each other. And it looks like this percent thing is some sort of indicator, some sort of wild card that indicates other things could show up there. So perhaps rather than looking for other, I want to see anyone that's a tourist. Maybe there's some tourists that show up in another category. And in fact, there are. A couple of people are not marked as others. They are, in fact, space tourists directly. So by poking around in these sorts of ways, we can start to get an understanding of what's capable with SQL and trying them out and putting your own restrictions or your own filters or your own sorting directly in here. But we can also go and do things that the Datasette API or the Datasette interface doesn't really let us do. For example, one of the things that I find interesting here is that we have both the flight that they flew up on and the flight that they came back on. But actually, there's a fair number of people that flew up on one flight and came back down on another flight. I find that sort of interesting. Can we get all of those people, everyone who flew up on one rocket and came back down on a different ship? And this we can't do, at least as far as I know, we can't do by clicking around through Datasette. But maybe we can start writing a query to do that. So let me get rid of a couple of these things that I don't care about as much. Just to make the output a little bit easier to read. And now I'm going to write my own where clause here. I want to see things where the ascend shuttle doesn't equal, and if you didn't know it, you can do that with the bang equals sign, the descend shuttle. And now if I run that query, this is giving me, well, not all, I think it's just the first 101 elements here, but all people who went up on a different flight than they came back on. And there's a bunch of things you can do with SQL that are not necessarily exposed through Datasette, but because Datasette lets you write these arbitrary queries, you can explore what you're learning about SQL all over the place. So SQL also has the ability to do aggregations. I can count up values across a large number of rows. So one of the things we have here, and I'm going to start rewriting this relatively quickly, but we have things like the hours in a mission. And let me add a comma, otherwise it's not going to work. Or the EVA hours in a mission. That's extravehicular activity. And now I don't want to filter it anymore. I want to see this from everything. So we can run that and we find just a couple of columns there. I might be curious, how many hours overall have people spent in space? How many hours overall have people spent spacewalking? How many missions are we talking about? So these aggregation functions, for example, I can take the sum of all of these with the sum operation, similarly down here. And I can also do an operation called count, just to count up the number of rows. And if I use star, it's just going to count all of the rows there. And run this. And now we get just a single row back because I've counted over just one of these things. Telling us how many hours people spend in space, and that is a fairly large number. In a little over 1,000, 1,200 flights. But what if I want to see this now, not overall, but say per country? For that, there's an additional thing we can add called the group by. Again, this is something that Datasette doesn't expose directly, but because we can write our own SQL, we can just go ahead and try it out. So we can try grouping by the nationality. Let's run that. Now we get a bunch back. Well, oh, which is which? Well, we need to add that to our select statements. Let's also select the nationality so we know which it is. And maybe to help us, we'll go ahead and order by let's just run it first so I can show you what's happening, and then we'll try to order it. So one of the interesting results here, we can see that the US has flown more space missions, perhaps, but the USSR and Russia had more time, cumulative time in space, mainly because they ran so many large space stations. If we want to order these, we can now replace that down here. So we could say order by the count. And you'd be tempted to write something like this, but that's actually going to fail when we run it. And Datasette will tell us the error that's coming up here. And the reason is it doesn't recognize that this thing count star should be the thing we're ordering by. We can use that same trick I showed you before, just give it a new name. We'll name this mission count. And then we can use this down here in the order by. This is, of course, going upwards. So we see all those nationalities that only have a single mission. If we want to see the top ones descending, will now show us those countries with the most missions flown. And it's about time for me to wrap up, but there is one more thing I want to show you, just to reinforce that we have a general SQL interface here. And that is, I might be curious about which people have flown together. At this point, I have a bunch of information on the individuals, but who flew together? And specifically, I want to look for people that flew together with people from other nationalities. So to do that, I'm going to have to use some information, right? I have their individual names, their nationality. And there's also a column, which is mission title, if I read my notes correctly. Oops, get rid of the order by at this point, because we are no longer doing that. Also, we don't need to group by. Sorry, trying to move too quickly here. So this is sort of information we have. And if we find two people have the same mission title, that means that they had to be on the same flight. And in SQL, we can match these up by doing what's called a join. And in a join, we will go find the values in one column in one table and match them up to values in another column in another table. But we can actually do a self join. We can join a table to itself. And I have to be a little bit tricky here. I want to give these two tables different names. We'll call one of them A1. And then we will join that again to the astronauts table as A2. And then we have to say which rows we want to match up. We want to say that A1 dot mission title equals A2 dot mission title. And what do I want to see? Well, I want to see both of their names, A1 dot name, A2 dot name, probably also their nationalities. So let's get that for both of them. And it's ambiguous because, right, it's coming from both of these things there. We do have to tell it, even though the titles are the same, we have to tell which of the mission titles we care about. Make that fix. So these are all pairs of people that have flown together. But, well, there's a couple problems. One is that we can match to ourselves, which we don't really want. But more importantly, we're getting the same, mostly the same nationalities here. So we want to look only where these two nationalities are different. So I can add a where clause here to say that A1 dot nationality does not equal A2 dot nationality. And if we run that query, now we'll find a bunch of people who have flown with people from other nationalities. So all that international cooperation is now showing up in this bit of data. Again, we get a URL for this that saves that information, but if I want to share it with someone else, there's a couple of export options here. So I can click the CSV export, and that gives me a big CSV file of this information. Or with this copyable option, there's a bunch of different formats that it gives us here of how to format this very nicely for different HTML output, for example, or different wiki outputs, or even with some fancy outlining of these things with ASCII notation. I think this was an even fancier one. There we go. So you can now share this information with people very easily. And with that, I'm going to stop my little demonstration here. Again, you can all play with this if you want. Just click that Start Code Spaces button on the repo, and you can have fun with your own data, upload it, play with it all you like. And with that, let's see if there are questions for us. So Raven, there's a question here about when the next full-time program will start after the summer session. Do you have those those dates handy?
Yes, and I'll finish up the presentation and then I'll go ahead and answer that question at the end. Just so we can make sure we get through this. But for the next, I'm gonna jump right into what a fellow is versus what a scholar is. So many of you have asked if we offer scholarships to any of our programs, and the answer is yes, we do. We admit two types of students into our data science and data engineering programs. Fellows are offered tuition-free scholarships to our full-time program, and we offer a limited number of these scholarships to our highly qualified candidates. So fellows are expected to leave any current employment to attend our programs and are expected to interview exclusively with our hiring partners. Scholars will pay tuition to participate in our program. So they are not required to interview solely with our hiring partner network and may maintain their current employment. Scholars still have access to the same curriculum, resources, and tools as our fellow students. Full tuition scholarships are not offered for the part-time program. We will be continuing to offer our Women of Excellence in STEM scholarship and the Equity and Diversity in Data scholarship for the summer 2023 cohort. These scholarships aim to help remove barriers and provide opportunities for women, veterans, LGBTQIA+, and students from racial and ethnic backgrounds that are traditionally underrepresented in technical roles. Our scholarship applications are now open, so you can visit our website at thedataincubator.com and you'll see a link or a tab for scholarships. Sorry, I think I froze for a minute there.
We still gotcha.
Okay, there we go. So next we're going to get right into employment rates. So a big component of our program that we really pride ourselves in is helping our students not only grasp data science concepts, but also get in place in that field. For our data science fellowship program, 97% of students that go through our program are currently employed outside of academia, and 88% are employed within 6 months of completing the program. That's part of the challenge, not only learning content, but being able to transition into a data science or engineering role. That's really where our program stands out because we will help you do both. So where are our graduates working and what are they doing? Our graduates are working in 55 different industries. Some of the most common industries we see are computer software, internet, IT, financial services, and biotech. Some of the typical job titles we see are data scientist, data analyst, research scientist, software developer, and product manager. These titles and roles vary depending on the company and industry, but these are some of the roles we've placed in the past. So this is just a short list of some of our data science fellowship hiring partners. As mentioned earlier, many of these companies are also hiring for data engineering roles. And then for financial assistance. So I know a few of you have asked if we have financial aid options, and the answer is yes. So in addition to our scholarship, we've partnered with Leaf to provide an income sharing agreement, and Leaf also provides you with 2 additional finance options. So you'll be able to participate in a tuition installment plan and a contingent payment plan. And of course, you can see all this information on our website, but if you want more details or have any more questions about these repayment options, feel free to reach out to us at admissions@thedataincubator.com. And before we end, I just want to just run some important dates by you all. If you're interested in applying for the summer cohort, our application ends this Friday, so April 28th. And then the coding challenge, if you're applying for one of our fellow spots, you'll need to have that done by May 1st. So I'll go ahead. We probably have like a minute to answer some questions. So I do want to start with a question that Rob asked about the next data science full-time program after the summer session. So we do run a cohort each season. So after the summer session, we'll start with our fall session. The application for that is going to be open on May 22nd. And the start date for that session is going to be on September 25th. Do we have access for the course video records after we complete the program? You will have access, but Robert, can you help with how long they'll have access? But you will have access after the program ends for some time.
Yeah, the videos are kept for a certain amount of time, and it depends on whether it's a full-time or part-time program. Full-time program, I think, have access to the videos for 60 or 90 days from the recording. I don't remember which. The part-time program have access to the videos for 180 days from the time of recording. So it is sort of a rolling window there, but we have so many courses, we can't really afford to keep all the videos hosted all the time.
And I think the next question is for you, Rob. What is the capacity of Datasette on SQL query? So I'll let you go ahead and answer that.
Yes, Datasette is a open source tool. You can use it on your own system. You can use it on a remote system. We were showing you today how you could go ahead and run this on GitHub Codespaces. Datasette itself is completely free. Codespaces is free for a limited amount of work. As I said, it's 120 core hours a month. So if you use the defaults, you're running it on a system with 2 cores, so 60 hours of usage of that a month for absolute free. If you want to pay more money, GitHub will be happy to take that money and give you even more time there. SQLite has some slight restrictions on the amount of data it can handle, but these are not restrictions you're going to hit in any sort of normal data analysis that you're managing. So it can handle more or less any piece of data you can throw it at least if you get it from a CSV file or an Excel file.
Thank you. And again, I know we're running a few minutes over, so we're going to go ahead and end the session. I do want to thank you all for joining us today. But if you have any questions that you were unable to put in the Q&A box or unable to get answered today, feel free to email us at admissions@thedataincubator.com. And with that being said, I won't hold you any longer. You all have a great day.
Thanks, everyone.